Once again, welcome to the Celebrate Earth Day with NASA's Globe Observer webinar. We're so delighted to see everyone joining us and to have many people from all over the country joining us. And we will be sharing some slides, so give me a moment here while I transfer over to another view. I truly apologize. I'm really having some technical difficulties over here with the with getting you access to the slides. Let me try one more time here. All right, my apologies. Now, if you could all just enter into the chat there, are you seeing some PowerPoint slides? Success. Thank you so much for your patience. So once again, welcome to this delayed start of our webinar. We're delighted to have you with us today. And we would like to just give you an introduction to not only clouds and observations, but how you can use the Globe Observer app in your programs. So basically, we're going to cover a little bit of the science, why look at clouds, why are NASA scientists interested in having us look at clouds. We're going to look at the nuts and bolts of the Globe Observer Cloud app, and then go through some ideas for Earth Day programs that you might want to have in your library. And I'm delighted to introduce you to our three presenters, Jessica Taylor, Sarah McRae, and Dorian Janney. And Jessica grew up in Florida, where she enjoyed watching the lightning storms, and went on to study meteorology at Florida State University. And she's been collecting data through the GLOBE program throughout that time. So she's here to share her love of science and working with the GLOBE program. Sarah McRae is the Education Outreach Coordinator at NASA's Langley Research Center. And she has also been a long-time observer of weather and clouds. And she is the Education and Outreach Coordinator working on NASA projects where she gets to do lots of things with weather and looking at clouds from new perspectives, including the ground, air, and space. Dorian Janney is the Senior Earth Science Education Specialist with ADNET at NASA Goddard Space Flight Center. And she jokes that she's always been accused of having her head in the clouds and having lofty ambitions. She recently went skydiving, so if any of you shared that experience, please do pass on your experience as well. She has taught for 3 decades in Montgomery County Public Schools in Maryland, and then transitioned into her new career working with NASA Science and Exploration on the education side of things. So welcome to all of you, and let me just transition everything over here so that everyone can see Jessica's slides to begin with as we go over some of the science. All right, Jessica, I'll go ahead and advance your slides as you're ready.
Wonderful. Thanks so much. As Kellyanne said, I'm Jessica Taylor at NASA Langley's Research Center, and I'm a physical scientist here, and I've been so proud to be a part of the GLOBE program, and as she mentioned, I've actually been doing GLOBE for longer than I've been working at NASA, so that's pretty exciting. So if you would go ahead to the next slide. We're here to talk today about clouds, and I want to share with you a little bit of the science. But before we get started on the science side of the house, I wanted to get a feel for what you already know about clouds. And so if you would go ahead and type into the chat box something that you already know about clouds. Maybe you could even describe the clouds in that chat. So I'll give you a few seconds to go ahead and type some things in. I see fluffy. They're made up of water vapor. Pretty. They have different names. Some of you even know some of the names already. What do you already know about clouds? They can bring rain and snow, so different types of precipitation. Form at different heights, yeah. I'll just wait another second or two to see if anybody else wants to join. So clouds to me are one of the most interesting features about Earth because as seen from space, you can see them here and they don't ever have the same pattern on Earth. They're ever changing. They're really important to our understanding of weather. I like to think of them as basically they are one of the main components of weather. And, you know, they do change not just on a daily basis, right? But if you came into work this morning and as you're leaving work this afternoon, they're going to look different. And so it sounds like you guys already know a lot about clouds. So go ahead and if you would advance the slides, please. Some of the descriptions that you guys have already shared with us about descriptive words. So words like fluffy or adjectives that relate to cotton balls and things like that, those are going to be your cumulus type clouds. Those are the types of clouds that are formed by convective. So if you're watching me on the screen, I'm doing this with my hands, is heating, mixing and heating together. Those are the cumulus clouds. And then, so those are your fluffy. The other adjective word you could use is flat. Blanket-like clouds. Those are your stratus clouds. And a lot of you already talked about how they can be at different heights. So here on the graph we have clouds at the different altitudes. And so the altitude and then what they look like, that fluffy or flat, is basically how you determine cloud type. So you guys are in a great position already because you already know a lot about how to identify clouds. So if we could move to the next one. The water cycle. Water on Earth is always moving, actually, right? It's changing from a liquid to a vapor and then back to liquid, either as snow or ice near the poles and the mountains. And that is the hydrologic process, or what we call the water cycle. And clouds are a really important element in that because they are the ones that bring, as many of you already said in the chat, they bring with them the rain and allow that water to come back to the ground. This is one of the key components of clouds in what we call the Earth system. And we want to talk about another component about clouds and energy. So if you would skip to the next one. Oh, back one, please. Thanks. Clouds and energy. And what we mean by that is the sun's energy. So at any moment in time, about 70% of the Earth can be covered by clouds. And in fact, if we removed all the clouds, if we constantly had cloud-free scenes, no clouds in the sky, we think that the Earth would be about 3 degrees cooler than it is already, because those clouds are blocking. For the most part, the clouds are reflecting. So it would be about 3 degrees warmer than it is already. If you look on this diagram, on the right side, you see those fluffy clouds, and you see that there's this yellow arrow of incoming solar radiation. That just means sunlight. Sunlight coming from the sun to Earth bounces off of these really big fluffy white clouds and it gets reflected. That arrow that says reflected solar radiation. And so those fluffy clouds, for the most part, help block sunlight. And you've experienced this before. So you've probably been outside on a really hot and sunny day and a big fluffy cloud rolls overhead and it provides you with shade and you think, oh, goodness, it finally feels cooler. So if we removed all the clouds, it would feel warmer. But that's not true of all clouds, and this is why cloud research is really exciting, is that we also have clouds like those on the left side. Particularly high clouds are very what we call transparent. They let a lot of sunlight in. So you see that yellow arrow on the left side where it says high clouds. You notice that yellow arrow of incoming solar shortwave radiation, again, sunlight. Most of that sunlight passes right through the clouds and still gets to Earth. So not all clouds are the same in terms of how much sunlight gets to Earth. If we have high, thin clouds on a day, we can get more sunlight than if we have those big, fluffy clouds that are basically blocking the sun. And so in terms of what's really happening right now in science related to clouds is we're trying to really better understand what types of clouds are out there in the environment, and then also trying to see if there are changes to any of these cloud types. If any changes in the Earth system are causing changes in either the location of clouds or the types of clouds that form, because that can really impact the temperature of the whole planet. So let's go ahead and on to the next slide. And here's another reason why we really need ground observers for this. So we showed that image of puffy clouds and high-level clouds. These are images taken actually from a satellite. And I'd like you to use the chat box and make a prediction of how much cloud cover you think is in each of those images there, the one on the left and the right, and percentages is what I'm looking for here. So in the image from space, the satellites that we have in space, many of them use instrumentation that is basically like a camera. They have a camera looking down at Earth, and they're taking images. There are also instruments in space that help to sense temperature, so they can maybe tell hot and cold. So this example is of a visible image, basically a camera image. So the question is, what's the cloud cover you think in each of these images on the left and the right? How much cloud cover do you think is in those scenes? We have a couple of guesses here. Someone said 60% for the left image, 50% on the right, 40% for both of them, 80% for the left and 40% on the right, 60, 55, 40 on the left and maybe 50 on the right. So this is pretty hard from space, right? Like looking at the answers that you guys are giving, it's hard. So if you could go, Kelly, into the next slide, and I'll tell you the answers. The image on the left actually only has 25% cloud cover. If you would go back one for us, Killian. The image on the left only had 25% cloud cover. The other white that you see there is ice. And on the image on the right, those are all of that white that you see for the most part is basically clouds. And so you can kind of guess that from space, we have a hard time looking at these images and figuring out what's cloud, because we can't just identify everything white as cloud, because that could be snow. And even if we were using an instrument that was measuring temperature, ice is also cold, just like those clouds that are made up of ice crystals or even cold water droplets. It looks really cold, but I bet that's something you know immediately from the ground, whether or not you are standing in ice. So go ahead and on to the next slide, please. This is what's really exciting about having two perspectives of clouds. Clouds that we have learned from instruments in space, and cloud information that we gain from you right here on Earth. Because you are looking up at the clouds, and the satellites are looking down at the clouds. So you know much better than the satellites whether or not there's snow on the ground. And it's also just a different view, right? So from the ground, and you look up, we talked about there being different clouds at different heights. You might see the low-level clouds, and if you had a sky full of low-level clouds, you would never even know if there were clouds above it. Well, the same thing happens to satellites looking down. If the cloud cover is completely full at the high level, they wouldn't know whether or not there are clouds below that. And so it's really important for us to get ground perspective looking up and then the satellite perspective looking down so we can actually get a complete picture of what's going on with the clouds. So I just have two more slides about the science side of it. And the next one is about what else might be in the sky. And so there's really, there's something called aerosols, particles in the sky. If you would click back one for us, Kelly Ann. Particles are actually really important because water droplets need to condense onto small little particles in order to make clouds. So water droplets condense onto these little particles in the sky to make the cloud. And so we do have particles in the sky, tiny, tiny particles. We have a book that likes to talk about how these aerosols, these small things in the sky, can be even smaller than the spots on a ladybug. So they can be very difficult to see individual particles in the sky, little pieces of stuff in the sky, just from the naked eye looking up. But these particles are important for clouds because, like I said, they allow us, for water really, to condense onto the cloud and make a cloud. And there are many, many natural sources of these particles. Here in Hampton, Virginia, we get a lot of sea spray because we're right on the shore, but it can be pollen, desert dust, volcanic eruption, natural fires. There are also human sources of aerosols, and that can be car exhaust or exhaust from factories. And also how we change the land can impact the particles that get in the sky. And the reason why we bring it up is that next slide. We wanted to talk a little bit about this because you can see that when you look up at the sky. You can look at something called sky color. And sky color is just the amount of blueness that you see in the sky. And what happens is if the sky is really clear, you see to the far left image here a deep blue sky. There are very few aerosols in the sky, and it's deep blue. If you were to have a lot of aerosols in your sky, it would start to get whiter in color. So you would go to that far end of the right, the milky. And the reason for that is aerosols reflect light. They reflect all wavelengths of light equally, and so you wind up getting a whiter color, a milkier color. And that's one of the observations that you can choose to submit when you're doing the Globe Observer app. So now I'm going to go ahead and turn it over to Sarah, who's going to talk more about the specifics of the app, how to get it, and what are the types of data that you can enter directly through the app.
So I think we're just taking a second to pull up the slides. Can everyone hear me okay? I'm seeing a few yeses. Great, thank you so much. Okay, great. So now we're going to move into the nuts and bolts of this Globe Observer app, which I'm so excited to be here because, and thanks for having me and thanks for joining us. I'm an atmospheric scientist turned education outreach coordinator. So my job is to help students, participants, the public observe clouds so that we're able to send that to NASA and be able to compare that with our satellite information and return that directly back to you guys as the participants. But one of the best things that we just created is this new Globe Observer app, this collaboration between the Globe program and NASA. So if you would go to the next slide, what I've done today is created a simulation for you, which is screenshots that'll let you see something similar. Oh, we're going to go back. Perfect. That is screenshots to show you something similar that you might see when you get to the app itself. So overall, this app is what you're going to do is it's free. It's for Apple and Android devices. If you go to either one of those stores, you would search Globe Observer right at the top there in bold. And with this app, you're able to take photographs of clouds, record sky observations and cloud observations. We'll kind of tag on to what Jessica was just teasing there a second ago, and compare them with NASA satellite imagery. So you'll get that imagery and that comparison directly back to your app. So I have the QR code here. Once again, this is being recorded, so you'll be able to access this later. And we also have URLs for you at the end of these slides. So you can go ahead and move to the next slide here. So through this app, you're observing your local community, and you'll be able to see it and compare it on a global scale. Where does your puzzle piece fit in? So how do you guys get this app as the library coordinators and facilitators yourselves? Also, how do your users get it? You'll be able to access it the same way. You download it from the app stores for free, and then when you come to the first page, you'll be asked to enter your email and a referral code. You want to scroll down until you see that picture there on the right of your screen. Your email and a referral code. So for this activity and for this event, you'll be entering Earth 2017, and it is case sensitive. So that's a lowercase EARTH 2017, no space. And what this does is it sends the account request to our Globe Observer app team, and you'll be ready to go when they send you an approval email back with your password to be able to log in. So then when you return to this screen, you'll be able to go to the top, enter your email, enter your password, and you are good to go. So we're going to move on to the next slide here. So what I've done is walk through an example, and what I really suggest is you guys get on, get your login, and be able to explore the app. But what we've done is walk through one example where you have clouds in your sky. So that's the simulation we're going to walk through today. So you're going to start with your observation. So you'll come to the home page, and it'll look like that first picture there, and it'll say New Cloud Observation. And as soon as you click that, your phone will populate your location using your phone's GPS. You're also able to manually adjust that with that Google Maps at the bottom there. And then it'll use this location to send you things like satellite overpass opportunities that we'll talk about at the end, and to find where your observation is coming from. So first and most important, date and location. Okay, we're going to move to our next slide. The second thing you want to do, and the easiest thing, is tell us what's in your sky. Are there no clouds? Which, don't worry, you'll still have observation opportunities under no clouds. Are there clouds, which is the example we're going to walk through today? Or is your sky obscured? So what we're talking about here is a phenomenon that blocks or clouds in the sky above you. And what we mean by that is anything from a heavy rain to snow to dust to hail. These opportunities and these options are all in the app for you. And we're asking if your sky is blocked 25% or more by those obscurations. So today we're going to focus on an example where you picked clouds. So we're going to move on, picking clouds, that center button there. If you wouldn't mind moving to the next slide. Perfect. So first, what it asks you is what percentage of your whole sky is covered by clouds? And your options are few, all the way up to overcast. So kind of tying into what Jessica was talking about, if you have a sky that's covered by few up to scattered amount of clouds, so 0 to about 50%, you'll have the opportunity to tell us about your sky colors and visibility, because what we're learning from this is information about the aerosols or small particles in the sky. So the other thing I like to point out about this too is you still have a great observation. If you have a clear sky day, you still understand some science and get to learn information about our sky, even if you don't have clouds in the sky above you. So let's say today we picked one of those first three options, let's say isolated, and I get to choose, I get to look at the bluest part of my sky, and I get to match it to one of these 5 options here. And then I move on and get to look across my horizon. So if I'm observing sky color, I'm looking up about halfway between straight up and the horizon, and I'm looking at the bluest part of the sky. And then for visibility, I'm looking across the horizon to look at a landmark probably far off in the distance, and I want to try and pick the same one from observation to observation so I can see a difference. I'll give you a little tip. When I do this, it helps to take a picture sometimes of my sky so I can compare it day to day. So we've observed visibility and sky color. Let's move on to the next one. So once I've done that, I get to go through my clouds. So it'll start me on high-level clouds. I get to click the pictures and tell what type. Am I looking at really high thin cirrus, really high cumulus, and it'll give you examples and pictures of those different types. It'll also ask you about contrails or condensation trails made by planes or aircraft flying in high altitudes. So we choose our type, we select all that we see, and then on the high level, again, it'll ask you on cloud cover on high level, and then it'll ask you about opacity, which opacity is a big word, or when we go into elementary schools, they're really great at this because they've just learned about light and shadows. So what we're talking about with opacity is how much sunlight that cloud lets through to the Earth's surface. Because tying back to Jessica's picture about Earth radiation budget, we want to know how much sunlight that cloud's letting in and how much of the Earth's heat is escaping back to space. And that's where opacity comes in. So we observe type, cover, and opacity on each level. What we mean by that is high, mid, and low. And then we're going to move to the next slide. And we wrap up our observation with surface cover or surface conditions. This is really important because this ties into that picture Jessica was asking you about by this satellite image. Are we seeing snow and ice, for example, or are we marking clouds in that satellite image? So by answering these questions, do we have snow or ice on our ground? Do we have standing water? These help give context to our satellite comparison. And the last and most awesome part of this app, in my opinion, is that it allows you to take pictures. You can upload pictures from your gallery already on your phone. We're asking you to take pictures of that same time period when you're entering your data, though. So you could save them and enter them later, but we want similar time period of when you're uploading the picture. Or if you click that green button that says Take Picture, it automatically ties your phone camera to a black circle in the middle of your screen with cardinal directions tied into it. And your goal is to get the green direction dot in the center of the black circle, and it snaps a picture for you. It's so easy and awesome. I love it. So you can either do that, or you can skip pictures altogether. So once we've done that, you can go to the next slide. You have automatically entered your cloud observation, sending it to NASA and Globe databases. Or if you have no internet or you're off wireless, no worries. The app stores your observation, and you can go back in at a time when you have internet connection, click your second button that says Review, Send My Cloud Observations. Then you would choose your cloud observation which one you want to send. It'll then make the button at the bottom green, and that information gets sent directly to NASA and Globe. So you've completed your observation. So we're going to go to the next slide. So how do you compare with that NASA satellite data we were talking about? Well, from your home screen, you can click See My Data. It'll pull up your data that you entered. It'll have your picture that you stored there from the ground, and directly under each observation, it'll have a link that says NASA Satellite View. And when you click that, you'll get an image like you see on the right here. It's basically Google Maps for satellite imagery, or Maps, Google Earth. And that red dot is tied directly to the latitude and longitude or location of where you observe from. So it's centered on your local observation, and you can zoom out and you can see how you're part of that global picture. So if you go to the next slide, that's directly in your app, that NASA satellite imagery. What are some next steps you can do? So once you're in the app, once you're taking those images, taking those observations and exploring, we invite you to explore satellite overpass times. This is important because this is how we're able to get that comparison, or that last picture Jessica ended on. So if you're looking at me in the camera, what happens is we're getting that satellite overpassing us, and if we observe during those times within our app, the satellite's looking down and we're looking up, and by having that same time period of observation, we're able to combine those two views and get a bigger, better picture of what's going on in the sky above us. So we have our satellite observation times, which you can try and tie to after you're comfortable. And then if you go to the next slide, I have two more here. Some of the extensions you can do is the app is also supported by a website. So Dorian's going to fill you in on a little bit more information about the website, but one of the cool things is you can go to explore data or see more data, and there's a whole global map where you can see all of the observations that are being sent in by others, yourself included, and it gives you a little more information and a few more links where you can tie to NASA satellite data. So the last slide here is just to review observer You can follow us along there where we try and upload updates, share cool NASA information, cloud information. So we'd love for you to follow us along there. So one thing I'm going to wrap up with, and I don't know if we made it a polling question, but usually a lot of your participants who come through are going to be asking or accessing this app through their mobile device. But what I'm interested in, because I have a few tips and tricks here, is how are you as a library facilitator or staff going to access the app in your program? What do you envision? Are you going to be using, and I don't know if this polling will work that well, so you might need to actually use the chat because we have two options in one poll question here. But are you going to be using an Apple or Android device? And are you going to be using your phone, or do you think a tablet or iPad would work best for you? So we have some options here in the polling, but what I think it might work best is in the chat, just enter some of those options that you think or you foresee would be easiest for you to use. So it says we're planning on using Apple iPad, perfect. We have Apple and tablet, perfect. Tablet, Apple phone, iPhone, tablet, great. So two things I want to leave you with is Apple, the update is available and out. When you go to the Apple Store, you're getting the latest and greatest Globe Observer app, and Android is coming out next week. So by the time you do your Earth Day examples and Earth Day programs, you'll have the latest and greatest Globe Observer app. And we definitely love when it's used on an iPad or tablet, just so that more people can see and handle and do and make observations, but phones work great too. So thank you all for letting me spend the afternoon with you all. I'm going to tag on and pass this over to Dorian so she can walk through some examples of how this might look through implementation at your library. Thank you all.
Sure that my audio is working.
Dorian, your audio, I'm afraid, is cutting out, so why don't you go ahead and close down your video feed, and we'll see if that cleans up the audio.
All righty, let's give that a try. How does my, are you hearing me now okay?
Loud and clear.
All right, marvelous. Sorry about that, folks. That was the one thing we didn't chat about, was making sure that to be in a place where there was where you were using the Ethernet and not the Wi-Fi. But I think I have the best job because you've learned about the science, you've learned about the app, and now I get to help you kind of learn how the rubber hits the road in sharing with you how you might go about developing some Earth Day programs. And as you heard before, I was a classroom teacher, and in addition to having been a classroom teacher, I also now have the pleasure of going and volunteering at my local library in Damascus, Maryland, and doing some library programs. I do them for little people, 3 to 5-year-olds. I do them for elementary school kids. I've done a few for teenagers and tweens. and I've done a few adult programs as well. So I took some of my background knowledge from doing some of these. I also looked at some of the neat things that people are planning to do or thinking ahead that they might do, that they had listed in the spreadsheet when they registered for the program. And so we'll take a look at some of these ideas. Next slide, please. So these are some of the possibilities that you might consider as you're planning for a program. So you might think about doing a program for the little people with adult support, for 5 to 10-year-olds, tweens, teens, family groups, adult groups, and really, excuse me, this is a kind of program that will work absolutely fabulously for mixed groups as well. Next slide, please. So these were some of the steps that we went over. What you want to do, and I would suggest doing this soon, and that is go ahead and download the app from the App Store. Something I want to point out is that when you and your participants are downloading this app to use it, they will need to give an email address. And once they give the email address, they will also see a place where they can enter the referral code. The referral code is really important. The referral code is lowercase e and then the word Earth, no space, and then 2017. The reason the referral code is important is because we want to know, and your library wants to know, how actually your library won't specifically know, but we will find out as an overall group how many different observations have been made based on us reaching out and doing this library effort. So it's a way in which we're able to get a sense of how far did this spread. And that's why we ask that both you and any participant that you train enters that Earth 17 where it says enter an optional referral code. So anytime you get a chance to go ahead and update and upload this app, put in your email address, you enter the referral code, then it'll take a couple of minutes for you and for your patrons to get a password. And you'll only need to enter your password once, but this password will come to you via your email address. And so once you enter this password, then you're done, and then you're ready to go. Okay, before I do this presentation, we're going to go ahead and give you a poll question because I want to get a sense of right now, as you have heard this information, who are you thinking of having a program for? And so you can say, are you thinking of preschoolers, elementary age, tweens or teens, adults or family groups? Go ahead, please, and enter your answer into the poll. And I'll give people about 30 more seconds. And Kellyanne, I don't know if it's possible or not to show the results of the poll. Just kind of a neat thing to do to get a sense of what people are considering right now before I go over some of these possibilities. And I'll wait a minute, or not a minute, I'll wait a second or two. It's a little hard for me.
Are you all seeing the poll questions, or the results anyway?
Now we're seeing the results. Wonderful, thank you. Okay, so looks like we don't have anyone looking at preschoolers now. We've got some folks thinking elementary school kids, some adults, some family groups, and some no answers. All righty, let's move on to the next one, and let me give you a couple of ideas for some of the ways in which I think you might be able to address working with all of these different audiences. So if I can have the next slide, please. If you were going to be working with little people, you might read them a story like "It Looked Like Spilt Milk." I used to read that when I taught my preschool and my kindergarten students. After that, you might have them look at some pictures of real clouds, or if you're in a place with windows, look out the windows. Talk about what clouds are made out of, you know, that sort of thing. Oops, go back, thank you. Then you might have them do an art activity involving clouds. With little people, it could be having shaving cream on the table and drawing clouds. It might be having them work with cotton balls, maybe make a mobile. We'll be showing you in a couple of, in a little bit here, our website where we have lots of ideas for various activities that you could do for the entire continuum, working from little people all the way up to your older folks as well. I would suggest that while you are reading the story and doing this activity, you would have the adults who are staying there while their kids are there. And that's often the case with the little people I have found when I'm working with little people at my library, and that is the parents kind of sit in the background. So we will have posted on our website a piece of paper that has the directions for how the participants will go about uploading the app and entering that referral code. So if they go ahead and upload the app and enter their email address and that referral code, they wait for their email to come back with their password, they should be ready to go in the 20 minutes or so that it takes to read the story and look at your pictures of clouds and, you know, do your art activity, and then you're ready to go outside and do a cloud observation. Something that I have found when I'm doing these observations with parents and with kids is that the kids and the parents love it when they have had the chance to upload this app on their own device, and then they feel this sense of real, you know, stewardship and ability in their you know, or a real sense of ability in being able to do this by themselves. Something I would stress: do not worry about making perfect cloud observations. You will not ruin scientific research if that happens. What we really want you to do is to get out there and have your patrons get out there and take these observations and start to marvel at the wonders that are out there. And the more they look at clouds, and then because they've entered their email, they will sometimes be getting back an email from NASA showing them, here was what NASA saw, and here's what you saw. And they will become better and better cloud observers, as will you. So please don't worry about making mistakes in the kind of opacity that's out there, what the clouds look like. This is really meant to be enjoyable, and very truly, your little people can go out and they can help by looking at the pictures, and it's just a touch screen that you're able to push on your phone. So by looking at the pictures and looking at what the clouds look like up above, they'll be able to do a great job in making that match. Next slide, please. So let's say you're working with elementary to tween groups. So again, you're probably going to have this issue with kids either not having their own cell phones, or maybe they have cell phones, but if I were a parent, I would not want to have my younger child put their email address out there. Knowing it's a NASA app, I think I personally would feel safe. But in any case, this is a place where parents have a right to be very cautious. So what you might do is let the parents know ahead of time that this is what is going to be happening. You're going to be doing this activity, and it would be nice for their children to be able to go out and use their devices or their parents' devices and take these pictures. So perhaps you could go ahead and ask them to go, you give them those directions ahead of time. You'll be able to have them online, so you could email them to them after they register. On the other hand, you could pass it out to the parents when they come in and just say, hey, could you come back in about 35 minutes and have this app uploaded and ready to go? and then we can all go out together and take these observations. So you might start off with these kids then talking about, what are clouds? How do they form? Why are they important? I sometimes find that having students or kids of this age talk to the person next to them and answer some of these questions, and then answer the questions as a group, that you're apt to get a much more lively discussion. With these age children, I would explain to them that, hey, NASA satellites study clouds from above, and they need observers from below. I would show them some of that satellite overpass information that we were talking about. You could do this by simply having this already uploaded on your own phone, or perhaps if you had a couple of tablets, that would be great because you could pass them around. But in any case, you don't have to show the overpass info, but it's neat for them to have this sense of understanding that NASA satellites are flying over us all on a regular basis. For my area, when I look at my satellite overpass, I see that usually there's about 9 satellite overpasses every day. And the kids find that really interesting. I would also show the Why Observe short video. And could you go, please, if we'll give it a try and see how our technology is working. If we can go to the website, I just want you to take a look at what we call the StarNet Library Earth Day landing page. And the reason I want to show this to you is so you'll see where all of these wonderful resources are located. We have videos for you. We have lots of different activities. We have a continuum of different options that you can pick from that will allow you to have lots of choices in what kind of program you do. That's okay, don't worry about it. No worries. I see we're kind of running out of time, so I know everyone can go to that website when they get a chance. So then after that, I might do a cloud identification activity with the kids before we go outside. You'll see we have multiple formats for that. It can be pictures. It could be a PowerPoint presentation. We have it already made for you. Or you can even go online and have the kids look at different pictures, and then there's kind of radio buttons that they push to say which kind of cloud they think they're looking at. Then go outside and make an observation. And if you still have the time, energy, and inclination, you could come inside. You could make a cloud teller. It's one of those little things that we used to kind of call them fortune tellers. You make it, has the little corners, and you go back and forth. And we have different pictures of clouds that's ready to go, ready to be copied for you. Or you could make a cloud mobile, or whatever you felt like doing. Okay, next slide, please. Just a few more slides here. Another thing you might do is if you were working with adults, seniors, teens, you might have a book club meeting. I have gone, looked at one of our wonderful NASA repositories called Earth Observatory, and I have made a list that has 11 recent articles about clouds. Some of these, well you'll see. It's a list that we have. It's in our facilitators guide. And it will also be up on the website, and you could pass this out as a PDF. You could send it out if you have a regular book club that meets, or if you're going to do that for Earth Day. Send them the list, and they could pick and choose which articles to read. You could even have copies of one of the articles and read it before or during the meeting. You could watch one of the short videos that we have, learn about clouds, talk about their impact, and then make sure everyone has started that process of uploading the app when they kind of first come in, so that they get their email and they've got it ready to go. And then they can go out and make their observations. Next slide, please. Adults, you might start, again, as I'm pointing out here, having them upload that app ahead of time. There is we have a couple of different videos. The Real World Citizen Science video is 4 minutes, 28 seconds, and that one is better to use with the older and adult groups, because here we're looking at the importance of engaging citizen scientists and how they are helping assist NASA researchers. You might, at this point, go over the app. We do have a PowerPoint on the website for you that you could use to help with that. Show them the different parts of it, like Sarah did. Here's how you make your cloud observations, satellite flyovers. And then go outside, do your observations. And again, if you have a time, energy, inclination, you could come in and read an article. You could also make a copy of that, of a PDF copy of that list that I will have, the article list, and give that to them so that they could interact with that later. Next slide, please. And just wanted to finish up telling you that we have, and you're just going to have to click through this, we have a facilitator's guide that we have developed, and the first section of it, if you'll give it a click please, is going to be background, so you'll have a little bit of background science information. Then we talk about materials. Really, all the materials you have to have are a cell phone or a smartphone or a tablet, and a sky to go outside and look up and look at. And of course, have your app downloaded and give it a try ahead of time. Next, push again. Audiences. Remember, there's lots of different audiences you can work with, and we have some information on some ideas of working with different audiences. Push again. And tips for what to do the week before, the day before, and even the day of your program. So it's really going to be easy. We've tried to make this as easy as is possible, and we would love any suggestions you might have. So as you take a look at this, if you have any suggestions, just send them to the StarNet, folks, where you with the email in which you registered, and we would love to take your suggestions, since we do have a little over a month to make some more materials and get ready. That way we will do the best we can to make sure we have everything ready for all of our librarians and their patrons. And if you'll push it again, please. Safety tips and then some programming suggestions are all in the facilitator's guide. And next slide, please. So just a few problems and solutions. Children and teens may not have email addresses to use. That's fine. So again, using the parents' email address is fine. They are not going to be getting any emails other than the email that gives them the password that they need only that one time to enter, and then they can get the emails from NASA letting them see the correlation between their observations and the observations that the satellite has taken. And an idea that you could do to go around this is send out an email with directions for uploading the app on the tablet or smartphone, and ask them to bring it to the event when they register so that they have a device ready to use, or have a few tablets or even cell phones that have it uploaded already that people can use while they are there. Next slide, please. And maybe your library has no internet connectivity. Just download your app ahead of time. Have your patrons use their own service providers to access the App Store and the email. They can do that without worrying about having library Wi-Fi. And as Sarah said before, you don't need the internet to make your observations. You can send your data later when you have connectivity. Next slide, please. So have fun. Download the app now. Start to use it. Be sure you enter that referral code so that we can get credit. Those of us working here with you libraries, and all of your libraries across the United States will get credit for all of the observations we have. You have time to ask questions and get support that may come up. So you have a whole month and then some before these programs will happen. Teach a friend or a family member how to download and use the app. Lots of things you can do to get ready, and like I say, have fun. Don't worry about it being, 100% perfect. Have fun with it. We just really want your observations. And next slide, please. And that's it. What are you waiting for? Get out there and make some observations. Thank you so much. It was nice to spend a half hour or an hour with you guys and share some of this information with you.
Jessica, Sarah, and Dorian, thank you so much for presenting all of this great information and these program ideas. And for all of those who are participating in this webinar today, we're just delighted that you could join us and learn more about some cool NASA resources that you can take into your programs. Thanks so much for joining us. And if you do have a moment to stick around, there was at least one or two questions that weren't yet answered, so I'll go ahead and pass those on to the presenters. But if you need to leave to go attend other things, take care, and thanks for coming today. So for all of our presenters, we have a question here about the referral code. If you went into the app and you didn't put in that referral code, what would happen?
This is Jessica. Nothing would negatively happen to you at all if you don't enter the referral code, but unfortunately then we wouldn't be able to track to see that it is truly through this collaboration with StarNet Library that we've been able to make these globe observations happen. So you would still access all of the same information on the app. We just wouldn't be able to track from a metric standpoint whether or not this collaboration that we've been doing between NASA and with Kellyanne and everyone on the team, what it turned into. There's also a way for all of the libraries, you would be able, basically on the visualization side of the Globe House, everyone who is making a globe observation from the libraries, you'll be able to see that from the visualization side, so they'll know that that they have participated, that those observations are happening because of a library connection that happened.
And one other question, is there an Android app that's going to be available next week?
Yeah, so there is an Android app currently available. We have made some exciting updates to the app that have allowed observers to make observations related to that sky color that we were sharing about, also adding in opacity, and really that being the ability to do matching with the satellites. Those updates just came out for the iPhone last week, and then they'll be out on the whatever the Android app is next week. So there is an app out there. There currently is Globe Observer. And so if you wanted to, you could download that one right now. But then what I would recommend is that you go ahead and update it prior to Earth Day, because you get a few extra cool functions with the updated Android app.
That sounds great. I'm also looking forward to that upgrade. So one other question from the chat. Should or can patrons create a new account?
The question is, can patrons create a new account within Globe? Is that it?
Should they create a new account? Catherine, if you have any other thoughts.
Oh, yeah, I think so. Yes, so if I understand the question correctly, when you go to download the app, for every device basically that it's on, it'll ask you if you want to create a new login or if you already have a login. And so it's possible for you to use an existing login if you already have one, or say if your library has an existing login, you could log into a different device. But you just need one email address to create a new login. And I would recommend, as Dorian said, people take great pride in being able to make their own personal cloud observations. And so if you have participants, if you have patrons visiting the library who are interested in downloading the app, I would say please encourage them to create their own login so that way they have it basically personalized to them, and they would be tracking to see how many observations they made.
This is Sarah McCrae, and you can share with them the same referral code, just so it ties back to the libraries and your efforts as well.
And this is Dorian. One of the things I did is I found that initially I hadn't entered a referral code, so then I just went ahead and used another email address I have and used the referral code with that one. So it's also, it's just that it kind of goes with your email address.
Well, thanks everyone for your all these great tips to leave everyone with. I am just going to post in the chat a SurveyMonkey link. If you could please just visit that SurveyMonkey and tell us a little bit about, what you're thinking about these resources, how you can use them, if you're planning on using them. Here at StarNet, we're looking very much forward to working with the NASA Earth Science Education Collaborative in the future to continue to put together resources for you to use in programs relating to Earth science and using NASA resources. So please do give us that input and just take a few minutes to let us know how it's going. Really appreciate, again, that you spent the time with us today, and I hope you have a great one.
Thank you, Kellyanne. Thanks for having us.
Thanks. We'll look forward to working with you.
Yeah, thank you.
You are too. Thanks so much, everyone.
Bye-bye.